Hi science students. Today we're going to focus on half-life of radioactive atoms. We're going to go through this simulation in order to fill in a portion of your assignment for today. So on your assignment for today, you're going to see a table. It's on the first page down towards the bottom right, and you're going to see that in this table, it already has element A filled in as your example. So we'll start with element B, but what you should notice is that at year 0, all 4 of the elements have the same number of radioactive atoms. They all start with 100, and then as the years pass, they're going to vary in the number of atoms remaining. So let's go into our simulation, and we're going to go ahead and start. We're going to go into element B. Element B shows me these 100 radioactive atoms, and so I'm going to click this little calendar down here, and 1,000 years have passed. Because of the coloring on the screen, I want to make sure that it's easy to tell which atoms are no longer radioactive, so I'm going to click my little X here and they'll disappear instead of just shading a lighter color. I'm going to click on this count the remaining radioactive atoms, and as of right now, there are 50 atoms remaining after 1,000 years. Pause the video if you need to record that into your data table here. We're going to click it again for 2,000 years, and we're going to remove the atoms that are no longer remaining. We're going to look at the remaining radioactive atoms. There are 25 left. Record that data. After 3,000 years, I'm going to see fewer, 13 atoms. After 4,000 years, 6 atoms. 5,000 years, I can count them, 3 atoms. 6,000 years, 2 atoms. 7,000 years, 1 atom. 8,000 years, 0 atoms. So in my data table here, after 8,000 years, I want to put in 0 atoms, all the way down to 20,000. Let's go on to element C. Element C has 100 yellow atoms here. We're going to do the same thing. We know at 0 years, we have 100. At 1,000 years, we have 85 remaining radioactive atoms. At 2,000 years, we have 72. At 3,000 years, we have 61. At 4,000 years, 52 remaining radioactive atoms. 5,000 years, 44. 6,000 years, 38. 7,000 years, 32. 27. 9,000 years, 23. 10,000 years, 20 remaining atoms. 11,000 years, 17 remaining atoms. 12,000 years, 14 remaining atoms. 13,000 years, 12 remaining atoms. 14,000 years, 10 remaining atoms. 15,000 years, 9 remaining atoms. 16,000 years, 7 remaining atoms. 17,000 years, 6 remaining atoms. 18,000 years, 5 remaining atoms. 19,000 years, still 5 remaining atoms. 20,000 years, 4 remaining atoms. If you need to pause to record, please do that. We're going to move on to element D. If you need to rewind to record, please do that as well. So element D shows us 100 blue atoms. So after 1,000 years, we're going to have 95 remaining atoms. 2,000 years, 90 remaining atoms. 3,000 years, 86 remaining atoms. 4,000 years, 81 remaining atoms. 5,000 years, 77 remaining atoms. 6,000 years, 74 remaining atoms. 7,000 years, 70 remaining atoms. 8,000 years, 66 remaining atoms. 9,000 years, 63 remaining atoms. 10,000 years, 60 remaining atoms. 11,000 years, 57 remaining atoms. 12,000 years, 54 remaining atoms. 13,000 years, 51 remaining atoms. 14,000 years, 49 remaining atoms. 15,000 years, 46 remaining atoms. 16,000 years, 44 remaining atoms. 17,000 years, 42 remaining atoms. 18,000 years, 40 remaining atoms. 19,000 years, 38 remaining atoms. And at 20,000 years, we have 36 remaining atoms. At this point, your data table should be completely full. If you have any questions, make sure you direct those to your teacher. Stay safe and have a good day. Bye-bye.